Hello everybody. Just before the main feature begins, I'd like to thank everybody who commented on the microphone video, my previous video. I think I tend to agree with the comments. It does sound a lot clearer and brighter than the normal built-in microphone on this camera, so I'm using it at the moment. And just before the video begins, I'd also like to say that when I was filming the screen of the scope, it appeared clear on my viewfinder, but it was fairly fuzzy on the video. I'm sorry about that, but I'm not going to redo it. It was too much hassle in the first place. So now on to the main feature. Hello again, and these are the speakers I built using those Focal 8-inch woofers and a couple of tweeters I had, which I've no idea why I had. But they didn't come out too badly. I mean, I'm not a carpenter. I actually made the boxes out of MDF, which I've never worked with before, but they could have come out better. The paint's not perfect, but you know, for me it's more important how they sound than what they look like. Hang on a minute, there's some noises. Yeah, so anyway, yeah, you can see the paint isn't great, but and they're very heavy. I had to put a screw into the wall, which they hang on, but I wasn't going to trust that, so I put some wooden blocks underneath as well to hold them up. And I think they sound extremely good. I'll play a bit of music in a minute, but these speakers I'm going to try and probably fail to measure their frequency response with that microphone which I looked at in the last video. I'm probably doomed to failure because I'm not in an anechoic room, am I? I'm going to get all sorts of reflections. I haven't got a calibrated microphone, and so on and so on and so on. But I think I'd like to do it just for the exercise. So what I use them for really is just listening to the radio. Or I can connect them to the computer and listen to whatever I want to listen to on the computer, which is not very much, mainly when I'm testing my playbacks on my videos or whatever. So now I'll go back into the workshop and I'll show you the equipment, what I've devised for testing the speakers anyway. So back in the workshop, and well, first of all I had to build a microphone amplifier, didn't I? That had a flat response, and so I come up with this. This was on TI's website, application notes, and it uses an op amp as an amplifier. I'm not sure how much gain it's got, but you stick about 15 millivolts in that end, you go about a volt out that end, so it's good enough, isn't it? And no idea what this chip is, other than being an op amp. I just used one I happened to find, and it works fine. And it's got quite good specifications, this amplifier. 20 Hz it's 0.5 dB down, 20 kHz 0.1 dB down, and it seems to be around that when I've measured it, but there are problems measuring it. And obviously we've got a bit of frequency compensation here on the feedback to give it a flat response, and as it's driving a condenser it needs a bit of biasing DC on the output where the mic plugs in. So enough of that rubbish, and I knocked this thing up in a couple of hours, so it's not pretty, so I warn you. And there it is. And I'm running it on a 12 volt battery. It takes hardly any current, about half a milliamp. As I said, it's not pretty because I didn't really care what it looked like, I just wanted it to work well, and it does work quite well. And originally I had a phono input because I was using this little condenser mic to try it out, but the new microphone of course is 3.5, so I put a socket on that for 3.5 input. So now, in order to test my test setup, I needed to do a frequency plot, and of course my scope over there has a spectrum analyzer in it, and it's one of the few lower cost scopes that has that facility. So, and if I put it into peak hold mode, and then do a sweep on the function generator that's connected to the mic amplifier, I can get a response then of the amplifier, in theory. But what I found was, and I'll show you in a minute when I'm putting the screws back in the box, is that I believe the mic amplifier is flat from 20 Hz to 20 kHz. I don't think the signal generator is, which is a bit of a shame, but I don't think it varies much by more than about a dB from, what have we got it set to? Start at 20 Hz, till starts at 10 Hz, fine, and stops at 20 kHz. And then I'm going to do the sweep at, I think I'll do the sweep at 200 seconds, because if I do it too fast, then the spectrum analyzer hasn't got a chance to catch the signal as it goes across. Anyway, let me wire all that up and we'll do the sweep of this amplifier. Okay, everything is now set up. I'm in spectrum analyzer mode and max hold is turned on. So if I start the sweep from 10 Hz to 20 kHz, you'll see what happens. And you can see it's plotting a nice graph now, which is going to take 200 seconds to do, which is 3 minutes and a bit. So let it get on with it and I'll come back when it's finished. So that's the sweep from, I don't know, 10 Hz to 20 kHz, yeah. Yes, it's span, whatever. And it's a wiggly line. Now I know it's not the amplifier because I've tested the function generator without the amplifier in line and you get the same result. So I'm just going to have to put up with that. But it's not as bad as it looks. I'm on 10 dBs of division, which is probably not really appropriate as I'm measuring voltage, not RF power as I would normally be. So probably 20 dBs of division would be more appropriate. If I bring up some cursors and I select a cursor, if I stick one of them on one of the peaks, which is at 7.7 kilohertz minus 7.6 dB sub volts. And then if I select another one, no, I shouldn't have done that. Back to that again. And move the other cursor to one of the dips. Or we could take it right up to the end, to one of those dips. And that one's down a fair bit. That's the second cursor, 19.6. So I'm getting an actual variation of 2.8 dB, which is not great, is it? But it's just the way the function generator works, I'm afraid. But I mean, testing frequency response on a speaker, there's going to be all sorts of errors anyway. So I don't think I'm too concerned about any of that. So now, the next and final part is to carry all this junk upstairs and try and do the speaker measurement. Right, back upstairs, and there's the microphone. I'd say it's roughly a metre from that right speaker down to the oscilloscope. I get a lot of reflections from the windows. I'll just do a quick test at 1 kilohertz, not in the spectrum analyzer mode. I was picking my voice up. Just the 1 kilohertz tone in normal oscilloscope mode. That's what we get. What are we getting? 60 millivolts RMS. I've got to do something about these reflections. I'll sort that out in a minute. Okay, it's the best I can do for reflections. I have to hold my hand at the right angle. Back in spectrum analyzer mode, we'll just do a quick sweep in real time mode. In other words, in non-max hold. That seems to work. I was just trying to get our levels right by doing this. Now I'm going to do it properly over a longer period. Okay, we're ready to go, and then I'll pause the video while it completes the whole thing. Okay, that's the complete sweep done. Interesting, isn't it? Of course, what I'm measuring here is the response of the speakers and the response of the microphone, so it's fairly meaningless and totally useless, really, isn't it? But it's something to play with. We have a nice peak there at 2.7 kilohertz, and it certainly was loud. I'm going straight into the speakers, by the way. I'm not going through an amplifier. I didn't want the amplifier to complicate things even more. So we got, yeah, it's pretty poor down at low frequencies, but maybe the microphone is. And peaks up there and drops off steadily down to 20 kilohertz at that end. And bring up some cursors, why not? Get rid of all this crap first. Oh, we got some, didn't notice that just now, because it was hidden, wasn't it? That's right. Okay. Yeah, I'm not sure about all this stuff here, but whatever. So, we move that marker to 2.7, where it peaked. .2, Then select the other marker and down at 20 Hz or roughly, we're 22 dBs down, and gradually climbs up 12 dBs at 940 Hz, and we get a lot of variation. That's 5 kilohertz, it's 14 dB down. And yeah, we got a bit better there, 10 dB down at 6 kilohertz. And another little peak there, only 8 dBs down at 7 kilohertz. And then just scroll through, 20 dBs down, well 18 at 12 kilohertz, and so on and so on, all the way through to all this crap at the end. Not sure how valid any of that is. So, as I said, fairly meaningless really, but just nice to play around, and it's nice to have a scope that's got a spectrum analyzer built in, not any of this FFT nonsense, which doesn't really do much good, in my humble opinion. I suppose for completeness, I should do the other speaker. I've saved this to the memory stick down here, so I can put it on the computer, and maybe we can look at the two graphs on the computer after I've run the other one. Okay, so that's the other speaker, and we're getting a peak roughly the same frequency, 2.8 kilohertz on this one. And I've now discovered what all this rubbish is. When it's sweeping at this point, it's creating loads of harmonics, and this is all harmonics, which are bigger than the actual signal, which is probably down here. So I don't know where the harmonics are coming from, but probably the microphone amplifier, I don't know. But it is what it is. Did I save? I need to save this, don't I? Okay, save to the USB. Alright, so that one's done as well then. Now I can stick those two on the computer, compare them. Alright, this is what I recorded onto the USB stick. And of course I forgot to turn all this rubbish off, didn't I? It did a screenshot. I left all that rubbish on. But yeah, and if I go to, this is the first speaker I did, the right speaker, and this is the left speaker. There is some difference. There certainly is a bit of difference. That one's got a lot of drop off there. And then they're virtually identical speakers. Of course, as we all know, I'm going to have reflections and all sorts happening, aren't I? But so it's all fairly meaningless and pointless, but what do you expect? Unless you got proper decent equipment to do these sort of things with. Still, it was an interesting little experiment, and not much else to say about it. Thanks for watching. Bye for now.